we were on the backside yesterday and we were working on these graphs. If you recall, on these graphs, the directions are asking us to find asymptotes and intercepts. So we're going to start doing that. We'll find some extra points as necessary. So with that in mind, let's look at B. And let's start by finding some asymptotes. Okay, what do you remember about vertical asymptotes? Okay, set your bottom equal to 0. So denominator equal to 0. In this case, that's going to be x plus 8 equals 0. Do your solving, and what do you get? X equals negative 8. Okay. Could you go ahead and put that vertical asymptote in while it's on our brains? You can. Go to the x-axis, and we're going to cross the x-axis at negative 8. Okay. Besides vertical asymptotes, we also need horizontal asymptotes. How are we finding horizontal asymptotes? Patrick?
The one with the biggest degree on top and bottom. You can find it.
Okay. So looking at biggest power, top and bottom. On top, our biggest power is the 4x to the first. On bottom, the biggest power is x to the first. So our powers are the same. They're matching. So since the powers are the same, what do we use?
Ratio.
We use the ratio of the coefficients. So 4 over 1, which is, in other words, y equals 4. So now on your y-axis, go to 4. And this is a horizontal asymptote. Okay. Let's review from yesterday, right? Those asymptotes we should hopefully begin to be pros at. Let's talk about intercepts. So officially the x-intercept happens when y is 0. What does that mean we were doing in this fraction? Okay, you've got to look for, okay, when is this fraction going to be 0? So when is the numerator going to be 0? So in this case, 4x minus 3 equal to 0. Add the 3 over. 4x equals 3, and x is what? 3/4. That is our x-intercept. And I don't remember if you're entering any intercepts on Savas or whatnot, how they want you, but you can, for me, you can say x equals 3/4, or it's the ordered pair, 3/4 comma 0. So if I go ahead and put this point on the graph, x-intercept 3/4, that means on the x-axis there's going to be a point between 0 and 1, right? Okay. Y-intercept. How are we finding y-intercept?
Let x equal 0.
Yeah. Y-intercepts happen when x equals 0. X equals 0 is an easy thing to do, right? Plug it in. So y equals 4 times 0 minus 3 over 0 plus 8. What do we get? Yeah, negative 3 over 8. So a y-intercept of negative 3/8, or if you want the ordered pair, it's 0 comma negative 3/8. So 0 comma negative 3/8. What am I doing there? On my y-axis, I'm going down a smidge. Okay. Now, with this in mind, Our 4 quadrants are a little skewed on this one, aren't they? But we know, okay, if you look at our asymptotes, we know there's going to be something in this bottom right section, yes? Because we have a couple of points there. And it's going to be a graph doing something like this. Okay? Now, where are we going to assume that would put the other one? If we have something here in the bottom right, then there's probably going to be something in the top left, which on my graph, it's kind of off to the side, but there's going to be something up there. Okay? If you're feeling the need for confirmation, okay, this is where I suggested step 3 yesterday, which are other points. Now, I'm not sure if I said it exactly this way in your class, so I'm going to make sure I do today, but to kind of confirm, I mean, I definitely want to do something over here to the left of this asymptote, because I want to make sure we're supposed to be in the upper left. This asymptote is at -8, isn't it? Okay, an easy thing to do would be something to the left of the asymptote, and then if we want more confirmation here, something to the right. So if this asymptote is -8, what numbers are directly on either side of -8? -9 and -7, yes? So those would be my suggestions of points to try. Now, I will tell you in this one, it's going to give me values that, you know, are a little bit bigger or smaller, whichever way you want to look at it, but plug it in. So what are we doing? If we're doing 4 times -9 minus 3 over -9 plus 8. Do the math. -36 minus 3, -39 divided by -9 plus 8 is -1. So -39 divided by -1 is going to be +39. Okay. And if we plug in -7, 4 times -7 minus 3 over -7 plus 8. So -28 minus 3 is -31 divided by a +1 this time, so -31. Now, let's look and see if those numbers make sense. -9, 39. So -9, 39 is going to be left 9 and up 39. Could that be possible? I mean, I can't even go up 39, but could there be a point way up here somewhere? Yeah. -7, -31. Does that make sense? Left 7, so it's right before the asymptote and way down here somewhere. That puts us in the right area, doesn't it? Okay. And again, we're just trying to get the basic sketch. So I know that there's something that goes... Okay, sorry, that was weird. I wasn't drawing while I was drawing. It's going to go way down there somewhere. Okay. This one over up here is going to be going in here somewhere. Okay. Again, this is sketches. Okay. But I want you to feel confident. Okay, we know where those asymptotes are. We know which 2 sections we're in. Okay, what questions do I need to answer here? Okay, for the moment. Shall we try another one?
What's the, so like how we draw our isotopes, they can never be like the same box, can they? We got our 4 quadrants, right? Because our new,
Kind of our new center.
our new center is there, but we can never have 2 in the same box, right?
2 what, pieces of the graph?
Yeah.
No, they're not. They're going to be in diagonal pieces. Well, with what we're doing right now, they're going to be in diagonal pieces. They technically, if these graphs were set up a little different, they won't be right now. They could both be up top or both be down low. But in what we're doing, they're going to be diagonals. Okay, that's what you're going to see. Okay, let's try these. Let's try this bottom one here. I know this one's a little wonky with the big numbers, so let's get a little bit more, I don't know, not big numbers. Okay, you got the process. What are we going to find first? Okay, let's find some asymptotes. I tend to start with vertical asymptote. You start wherever you want, but how do I find my vertical asymptote? Okay, denominator equal to 0, so x plus 3 equals 0, so I have a vertical asymptote at x equals negative 3. Vertical line, yes, vertical asymptote, so go to negative 3 and draw it. What about horizontal asymptote? See a couple people flipping back to the front all of a sudden. What's the biggest power on top?
0.
There is no power on top, right? It's just that negative 1 value. What's the biggest power on bottom? That x to the first, yes? Where is my bigger power? On bottom. Thus, some people are flipping back to the front. We've only had this one at a time. What's our rule? Y equals 0. Okay, so when your bigger power is on bottom, then it's always going to be y equals 0. Now, on the y-axis, where is 0? Here's my y-axis. I want to draw a horizontal asymptote at 0. Where is that? That is the x-axis, yes? Okay. So that's your horizontal asymptote. Let's check some intercepts now. Okay, x-intercept. How do we find our x-intercept? Okay, it happens when y equals 0. And since we're dealing with this fractions, it happens when the numerator is 0. What's my numerator? Negative 1. So I get negative 1 equals 0. Is there an x to solve for? No. So guess what? Does negative 1 equal 0? No. So there are no x-intercepts. Now, think about it. What is my x-axis? My x-axis is an asymptote. So there really won't usually be an x-intercept if your x-axis is the asymptote. Okay, so that makes sense. That's a good thing. Okay? When do y-intercepts happen? Right. Let x equal 0. So that means I'm doing y equals negative 1 over 0 plus 3. Negative 1 over 0 plus 3 is negative 1/3. Or if you prefer, it's the ordered pair, 0, comma, negative 1/3. So on the y-axis, we're going to cross the graph at negative 1/3. Very, very close to our asymptote. Okay. Now, in all honesty, if this is me, I can draw my graph right now. Because I know the shape. I know at least one point that puts me something in a quadrant. Can you see what's going on? Or are we not quite there yet? Okay. If we do a couple of other points, remember my suggestion. Pick points that are on either side of your vertical asymptote. So my vertical asymptote was what? -3. So what are points that would be on either side of the -3? Yeah. I wrote -2 and -4 because I was already writing it, but yep. So plug those in. See what happens. -1 over -2 is 3. What, that's -1 divided by +1, so that is a -1. And -1 over -4 plus 3. That is -1 divided by -1, which is a +1. Now, let's see if these points make sense. -2, -1. Left 2, down 1. That's good in my mind because it's in the same section as my y-intercept, right? -4, +1. Left 4, up 1. Does that make sense?
Yep.
Yeah, it's in a diagonal section, isn't it? Okay. And again, so this particular group is going to be very close to that new center point. Okay. And I'm not, it's going to look something like this. It's going to run very close to your asymptotes. As I said, something like that. If you're not feeling confident and you want to, like, okay, -4 gave me a point, you want to plug in -5 or -6, go for it. Okay, you can plug in as many points as you want. Know that today, and what we're doing, these shapes are the two curves going outward diagonally. Okay? Otherwise, these graphs look really crazy if you don't know that. But you have to know that. Okay? Are we about there? One more? Do you know enough to stay ahead of me on this one?
No.
No? I think you do. Okay.
Yeah.
I'm starting with asymptotes. Vertical asymptote?
X minus y.
Denominator equal to 0. So x minus 1 equals 0. So x is 1. It's a vertical asymptote. So if you want to go ahead and draw it in on the x-axis, go to 1. Horizontal asymptote.
3x over 9.
Okay, biggest power on top is the 3x to the first. Biggest power on bottom is x to the first. Like a lot of our examples have been, when the powers match, use the leading coefficients. So leading coefficients here, 3 over 1, or in other words,
3.
y equals 3. Okay, so if I do a horizontal asymptote at 3, I'm going to y equals 3, so 3 on the y-axis. Okay. Some intercepts and other points. Something to find. Where exactly this graph goes. X-intercepts. Well, I'll always say they happen when y equals 0. In a fraction, y equals 0 when your numerator is 0. So 3x plus 2 equals 0. Yeah, sorry, we've had lots of fractions. Subtract 2. 3x equals -2. Divide by 3, and x is -2/3. You can think of the ordered pair -2/3, comma 0 if you want. So if we go ahead and put that in, left 2/3 from the origin. Okay. When do y-intercepts happen? When x equals 0. So y equals 3 times 0 plus 2 over 0 minus 1. Two over negative 1, is that what you said?
Yep.
Which is negative 2. So ordered pair of 0, negative 2. Left, right, 0, down 2. Okay. I personally see where this graph is going. I have one piece figured out, right? And then my logic will tell me the other piece is going to be diagonal from it. Okay. If we check a couple of extra points. What kind of extra points did you check? Or are you checking?
0, 2.
So looking at what's on either side of my vertical asymptote, which is, my vertical asymptote is 1, yes? Now, like I said earlier then, 0 and 2. However, technically, don't we already know 0? Don't we already have that one? We do, okay? I mean, I can fill it in there as it's negative 2. If you want to do something else, you'd have to go over to like negative 1 or something if you want a whole number. Again, this is not the section I'm really concerned about, is it? I feel confident I know where that section is. Let's check 2. 3 times 2 plus 2 over 2 minus 1. 8 over 1, is that what it is?
Yeah.
So 8?
Negative 1.
I disagree. 2 minus 1 is 1. 8 divided by positive 1. Okay, 2, 8. Does that put you somewhere logical? Right 2? Up 8. Does that put me in that diagonal quadrant?
Yep.
Yeah. If you want to see where it goes, pick a bigger number then, right? Because if you pick a bigger number, you would be getting one of these values over here. Okay. And again, I'm not making us graph more points because these graphs don't have to be precise. Okay, we have the gist of where they are based on the asymptotes. We know those. We know which sections they're in. Okay, those are the key pieces to me. Okay, you have homework in Savas. It's out there. I know some of you have gotten into it and started it. Lesson 4.2. Get it done for tomorrow, please.